Oh, we are going live. So we're going to look at adding and subtracting rational expressions, okay? Which really just means adding and subtracting fractions, but in this case, the fractions might have binomial expressions in them. Nonetheless, the game is pretty much the same thing, slightly more complicated than the multiplying and dividing for one reason. Okay, Justin, I want to add 1/6 and 1/3. Is the answer 2/9? No. Seems too simple. Yes. Okay. What do we need when we go to add fractions or subtract fractions for that matter? We need a common denominator. That's right. Okay. So what is the common denominator for these two expressions? It is not 3. It is not 3. I cannot express this as something over 3, at least not conveniently. So what is the common denominator in this case? 6 is going to be the common denominator. So this is 1/6, and now I need to express 1/3 as something in terms of sixth, and it is 2/6. Now that I have a common denominator, I can go ahead. I have 1/6. I add 2/6 to that. How many sixths do I have? I have 3/6. Okay. I can simplify this because there are common factors in the top and bottom. Yes. Okay. And so this is 1/2. So there we go. There's our whole deal. We're just going to step this up, and we're going to put rational expressions in there. Okay, so Justin, I see you're taking your note now, but I'm maybe going to erase this right away because people have to look at it. Okay, you got it? Okay, I got this. Don't worry. Perfect. Okay, so I'm going to change it slightly. Just slightly. I'm going to turn this into a subtracting just so that this is a subtraction question, and I'm doing it just so that, yes, I put an X in here, and it's going to seem just a little bit more complicated, but really it's not. Okay, now what is my common denominator going to be? 3x is close, but it is wrong again. Yes, it's going to be 6x, okay? Yeah, okay. Yes, so this is 1/6. I want a 6x on the bottom, okay? In other words, what did I do to 1/6 to get this 6x on the bottom? I took 1/6. I multiplied the bottom by x, but I can't just multiply the bottom by x. I have to multiply the top by x, that's right, okay? Because so this becomes x over 6x. Sometimes people talk about like cross multiplication, but that might be just a waste of time. Okay, I have a 3x on the bottom, but I want this to be a 6x on the bottom over here. I have to multiply the bottom by 2, but when I multiply the bottom by 2, I have to multiply the top by 2. Yes, that's right. So now we've got 2 over 6x. Okay, so these are equivalent. I need to also say one thing. What value of x cannot happen? What's the restriction? I can have a 3 in there. That's fine. I can have a 6 in there for x. That's fine. -6, I can have a -6 in there for x, right? -3, I can have a -3. 0. I can't have a 0, right? Because this becomes 1 over 3. This becomes 1 over 0. So I can't subtract undefined from 1/6. So I should just say, oh yeah, x cannot be 0, or this will never work, never ever in the world. Okay, so Justin, good. We have a common denominator. Okay, I know that I have x divided by 6x. I'm taking away 2 divided by 6x. I know that it's going to be over 6x at the end. What goes on top? X minus 2 is as easy, as simple as I can possibly make it, okay? X minus 2 goes on top. There's my answer, okay? That's the answer. So you notice this business, you have to get a common denominator, okay? You could have also done the big crash, which is you just multiply these both together, and you would have gotten, you could have used a common denominator of 18x. Well, it's not. You just multiply this by this, and then you just cross multiply the tops. You'll still get the right answer, but when you get to here, you'll end up having to cancel extra stuff out. So there's nothing wrong with that technique as long as you're ready to simplify at the end. Okay, so we could have chosen, we could have chosen 18x as a common denominator. Okay, so if you're like, if you can't do it, just multiply the two bottom things together. You'll find your common denominator that will work. It just won't be great form, and you'll be dealing with big numbers, but it won't happen that much. So don't worry about it if that's what you have to do to get a common denominator. That is fine. Okay, because when we get into the binomial denominators, that's what you're doing anyways, and that's mostly what this is about. Okay, so look at this. Oh my goodness.
Do I have to look at that?
You have to look at that.
Oh.
I'm actually going to get those toothpick things, put them in your eyes, force you to look at them. Okay. Justin, what is my common denominator for these two expressions? Remember what I just told you. If you said 2n plus 1 times n minus 3 is the common denominator, you would be right. There are no like common factors between these two, so you are stuck. Okay.
Oh.
Yeah. So yeah, very belligerent indeed. So n minus 3 and 2n plus 1. Uh-oh. No, it doesn't. I'm actually making it backwards just so that it might make more sense. On the other hand, it might not make more sense. Okay, here's 3n over 2n plus 1. So there's 3n over 2n plus 1, and I've multiplied the bottom by n minus 3 to make my common denominator. Justin, I can do that, right? I can just multiply the bottom by n minus 3 to make a common denominator.
Maybe.
No, I can't. I can't. Okay, so I have to multiply the top by n minus 3. I have to multiply the bottom and the top by n minus 3. Yes. Okay, now, but that means over here, though, it's okay, right? When I multiply the bottom by 2n plus 1, it's okay, right? I don't have to do anything to the top, do I? Maybe. What do I have to do? Multiply the bottom by 2n plus 1. I have to multiply the top by 2n plus 1 as well. I did. So I'm taking 4 over n minus 3 here. And I'm multiplying the bottom by 2n plus 1 to get the same denominator. And then I have to multiply the top by that too. Okay, so now I'm all ready to go. 3n times n minus 3 plus 4 times 2n plus 1 all over n minus 3, 2n plus 1. Okay, so there's, you need to simplify the top, probably. Probably, okay. So this becomes 3n squared minus 9n plus 8n plus 4 all over n minus 3, 2n plus 1. Okay, and that simplifies again because I can collect my like terms. In other words, I can subtract these n terms. 3n squared is all by itself, minus n plus 4. And I'm just going to leave the bottom factored. There we go. Okay. So there's the first thing we've got going on. We've got binomials. We just find the common denominator. We hit it with the bomb. We just multiply the two things together, the two denominators together, and we automatically get a common denominator. In this case, it can't be any simpler. Okay, there are no common factors. So this is, yes, a form of the final answer. You know, I could have multiplied out the bottom, and there is no like right or wrong. It just depends on what people say, what they want you, how they want you to end that. Okay, Justin, ready? This is as hard as it gets. Yes, my child. For those of you who may be watching on the internet, Justin just invoked God. Okay. Okay, 2t over t squared minus 1 plus t plus 2 over, yes, it is. Yeah. T, it's a plus. T squared plus 3t minus 4. Okay. Right. So, as you probably guessed, this is the example where we are going to factor things out to find out if we have common factors in the denominator, because I do not want to just multiply this and this together to get my denominator, because I'll have to multiply the tops by that. It'll be a mess. So we're going to factor the bottoms, the denominators. We're going to look for common factors so we can find the least common denominator. Okay, Justin, I have faith in you. I know that you can factor this just by looking at it. T squared minus 1. T plus 1. T minus 1. It is a difference of squares, yes. Minus t plus 2 over. Okay, I need two numbers that add to positive 3 and have a product of negative 4. Yeah, yes. So, nice try. It's definitely going to start with a t. Two numbers have to multiply together to give a negative 4 and add to positive 3. So plus 4 minus 1. Okay. All right. Notice I have a common factor in both of these denominators. No, I can't factor it out. I cannot cancel it. Okay, that's something that could happen. I cannot cancel it though. But when I go to get the lowest common denominator, I am not going to multiply this by t minus 1. It's already in there, right? I'm not going to multiply this by t minus 1. It's already in the denominator, okay? But I do not have a t plus 1 over here, and I do not have a t plus 4 in this expression in this denominator, okay? What am I going to have to multiply this by? Bottom and top to get a common t plus 4. You, sir, are a steely-eyed missile person. That's right. I'm going to multiply this by t plus 4, top and bottom, t plus 1, t minus 1, t plus 4. Oops, t plus 4. Very good. Okay. Now, what do I need to multiply this one, top and bottom, by in order to turn it into the same, the same expression, but with that same denominator? You, sir, are a steely-eyed missile man. T plus 1. Steely-eyed missile man? Missile person? What on earth is that? It's somebody that releases missiles, I guess. They used it in the right stuff. Or, no, wait. It was Apollo 13. Okay. All right. So, for the people that are watching this tomorrow, you know, you can just basically expand the top and do all that subtraction thing. So we're almost there, okay? Our final answer.
Why do you keep on putting a minus sign between them? You're saying addition, but it's not addition.
It's a subtraction.
I asked that. You said it was addition.
Okay. Erase the little plus part and put in a minus. Okay. Okay. And what is this? Is this a t plus 4? It is. So there's the common denominator for that expression. To nicely combine these, we should expand them. So this becomes 2t squared plus 8t minus t squared. Oh, minus, I'm going to put a bracket around that just so that we can follow it. Plus 3t plus 2. 2t squared plus 8t. So I've just expanded this. And subtract, because I'm subtracting the tops. And I've expanded this expression here, t squared plus 3t plus 2. Okay, and I'm going to do the final simplification step over here. We are going to be equal to, so 2t squared minus t squared is, oh, that line is too crooked even for me. Okay, 2t squared minus t squared is t squared, and plus 11t. And, oh, sorry, because that's not 8t plus 3t. It's 8t minus positive 3t. So that should have been a 5t. Oh, I can't believe I did that. See this? This is subtraction. So 8t subtract 3t is what's actually going on there. Okay? And the last thing, there is no constant term here. There's no number like 5 or 6 or 9. So this is a 0, subtract positive 2. So it is 0 subtract positive 2. Justin, what is it? Negative 2. Correct. Negative 2. So t plus 1. I'm going to leave the bottom all factored out. So there's our answer. Okay? So in this case, to come to that common denominator, we factored the bottom. We look for common factors so that we don't wind up doing a bunch of extra multiplication. We multiplied top and bottom of the expression by that extra factor that we used to make the common denominator. And we just did our subtraction and simplified things. It seems like a lot of math, but this is entirely mechanical. You can make mistakes like I did here. Remember, I did 8t and then I added 3t because I forgot about the subtraction. Those are relatively easy to skunk out once you get doing them. Okay? Sound all right? Okay.